Hello again, and the topic of discussion is surface charge distribution. As you can see, our reference axis or reference frame is ready. The figure, this is a surface over which the charge is continuously distributed. I was a bit lazy, so I kept a space, but in actual, there is no space between the two charges. Okay, now here we will talk about a quantity which is called surface charge density, and it is symbolized by sigma. Sigma is defined as charge per unit area. So simple, charge per unit area. That means how much charge is there for a unit area. You can make the formula out of it, that is charge per unit area. Simple. Then we fallen for the unit. The unit of sigma is like charge. It is measured with coulomb, and area, that is meter square, but as it's in denominator, meter inverse square. Simple. Dimensional formula. Now, as we did it in the previous lecture, it is very simple. There won't be any dimension of mass, length minus 2 times time T1 and A1. Simple. Now, when we go for a specific derivations, we need to go for a concept, which is we use the sigma, but not like this. So what we do is we consider a little area element. We say that this little area is dA and charge over it is dQ. So in that case, we write down sigma is equals to dQ by dA. In some derivation and in some numericals, we'll use this. Stay tuned for the next one.